Hello everybody, welcome to our new topic, topic 6. This first lesson, 6.1, is on rational exponents and properties of exponents. So our learning target for today, we will be able to use properties of exponents to solve equations with rational exponents. We will be able to extend the properties of integer exponents to rational exponents to rewrite radical expressions using rational exponents. We will also be able to solve equations with rational exponents using the properties of exponents. All right, so let's get some vocab in your notes and some of these properties we were just mentioning in our learning target. So, an integer exponent. For example, you have x raised to the nth power. So just a couple of things. That x is what we call a base. The n is the exponent. And if this is an integer exponent, that means that n is an integer. So for example, you might have x to the third power. 3 is an integer. Just a reminder of what that means. That means you are multiplying your base of x 3 times. Or maybe we have 5 squared. So whatever your base is, we multiply that 5 the number of times that our exponent shows, whatever the power is. All right, then we have a power of a power property. So power of a power, let's say we have a base of x raised to the power of m, and then we take that whole thing and we raise it to another power. So these exponent properties, by the way, are shortcuts. We would prefer to use an exponent property versus having to do this out the long way. So when you have x to the m raised to the nth power, that is the same thing as x to the m times n. So you actually get to multiply those two exponents together. So for example, what that might look like with numbers is, let's say you have 2 to the third power, and then we raise that to another power. So that's a power of a power. That's the same thing as you always keep your base and multiply the exponents. That's the same thing as 2 to the 6th power. Now, if we were to do this the long way, I'll just show the long way on one of these so you can see. 2 to the third power, if you square that, that means you have 2 to the third times another 2 to the third. Well, 2 to the third means you're multiplying 2 3 times, and then we're multiplying another 2 3 times. So this is the long way. We can see, okay, so in the end, we're really multiplying a 2 1, 2, 3, 4, 5, 6 times, 2 to the 6th power. So we can get this 2 to the 6th power much faster by using our exponent property. All right, then we have a product of powers property. So what that looks like is if you have x to the m power and we're multiplying it by the same base, x to the n power, that's the same thing as you keep your base of x, but we will add the exponents, m plus n. So for example, let's say we have 5 squared times 5 to the third power. If you're multiplying the same base of 5, you keep your 5, but you add your exponents, 2 plus 3. So really this is the same thing as 5 to the 5th power. All right, a couple more properties to go. Our next one is the quotient. Quotient means fraction. Quotient of powers property. So if we have x to the m over x to the n power, if you're dividing the same base, you keep your base, and there's an exponent property, this one, this quotient of a powers property, that says we subtract the exponent from the numerator minus the exponent from the denominator. So for example, if we have, let's say, x to the 5th power over x squared, we would say, okay, well, we're dividing the same base of x, so you keep your x, you keep your base, and you subtract your exponents. 5 minus 2 leaves us with x to the third power as a simplified answer. All right, so those are our properties. Now we're getting to rational exponent. all of these properties we will apply to rational exponents. So what is a rational exponent? That is when the exponent is a fraction. So for example, you could have x to the 2/3 power. That is a rational exponent. So when you have a rational exponent, we'll just make a note. Let's say x to the 2/3 power. That fraction, the top number is the power, and the bottom number is the root that we're taking. So we can rewrite x to the 2/3 power, that's exponent form, as we're taking the x, raising it to the second power, and the denominator is 3, so that is the third root. So we put a little 3 in that nook of our radical symbol there. You also could write that as the cube root of x. That power could go on the outside as well, x squared. Those are equivalent statements.